Hey guys, welcome back to Let's Try Hardware Engineering. It's Michael, and we're going to look at this problem about numbers complements. So the little description here goes through a discussion about subtraction in binary, and it suggests that, okay, well, how would we represent a negative number in binary? And one of the ideas is, what if we just made one of the bits represent the sign? So 0 would be positive, 1 would be negative, but through various reasons that isn't practical. So what they didn't talk about is the fact that, for instance, on 1, 0, 0, 1, if you add 0, 1, 1, 0 to that, then you end up with 1 all the way across, 1, 1, 1, 1. If you use a NOT gate on that, then you get to 0. So effectively, we can make that happen here. But then there's another thing that needs to happen. On yet another example, we know that 1, 0, 0, 1 in binary plus 1, 0, 1, 1, 0 in binary equals 1, 1, 1, 1 in binary equals, if you use a NOT on it, zeros. If we can only get a 0 on the right-hand side, we would be done. And so there's several procedures that yield 0 as desired. The simplest one is to add the original, the one's complements, and then some number that uses 1 as the most significant bit, and there you have it. So what they're saying is 1, 0, 0, 1 in binary plus 0, 1, 1, 0 in binary plus 0, 0, 0, 1 in binary equals 1, 0, 0, 0, 0 in binary. After stripping off the leading 1, we get 0. How do we achieve the stripping off? We simply ignore the carry out of addition. So that is what they're saying about it. And then our little assignment here is only one page. We have a 4-bit input A. Let me get over there. I kind of wish there were tabs rather than these little arrows because the interface isn't super fast. 4-bit input A. That is this guy right here. So he's given us 4 bits in. We don't need another one of those. Thank you. Find a number B such that A plus B equals 0 and assign it to the output 0 or O, which is the output O right there. There we go. We also need to, it sounds like, get rid of the carry. So we can use this output ground here, which will throw the output of the carry into that. Now, it also sounds like we're going to have to do two different additions here. So maybe we need to... Maybe we need a little more room in here. So let's go in here and look at what adders we have available to us. So we have our 4-bit adders. We have a half adder and a full adder. Well, if we take our half adder, let me just put it down there, right? We can hook this guy up to here, and then we can just input no, we don't input anything actually. We're going to look for another component because I think there is another component in here under logic gates maybe that we saw. Right, a 4-bit NOT gate. So let's try this. If we take the outputs of this and put them right into the A inputs over here, and then take the outputs and put them through this NOT gate and into here, we should end up adding whatever this number ends up being, whatever they put into it, and its inverse to give us 0 output over here. And we can take the carry out and put it into another one of these guys, a full adder. And then I think as long as we just stick a 1 into this other guy, we should be all right. So let's try this. So if we take this guy and let's put it like there, all right, and we wire this guy up into here, and then we just engineer this thing we're adding to it using the input keys over here. We have high, and we have lows. Do we need lows for each one? I don't know, but we'll use them just so that everything is connected. So we need 4 of these guys to represent, basically, yeah, we need to put it right there. So we actually need to put it on this side, I think, if I'm not mistaken. Okay, let's try hooking all this up and see if it works. I haven't gotten this to work off camera, by the way, so I have not actually solved this puzzle yet. You know what? Let's give ourselves a little bit more room to play with. Can you delete that? Thank you. Okay, get out of the wiring tool. I'm going to move that down a little bit. I'm going to move this guy down a little bit more so that we have a little more room to play. Let's see. Okay, so we're going to bring like this guy up. Yeah, all right, like that. So I'm going to do the wiring from here up, and then I'm going to pull off of it and go up to here. We're going to connect these to here. We're going to make C out go to CN on this guy. We're going to make this number go into here. We're going to make these guys go into here. We're going to bring that up to there, and we're going to drop C out into the ground over here. So I'm going to go off camera, wire all this up, and then we'll come back and test it out. Be back in a minute. Okay guys, I'm back. I'm not entirely confident this is going to work, but let's see if we can follow the logic here. So this guy is producing us a 4-bit number. It's going to put it out onto these lines. It's going to go unmodified into this half adder right here without a carry in. It's going to get flipped, inverted by this NOT gate here, and go in here. They're going to get added together, and the result is going to be 0. The carry out is going to be 0, so that's not going to really matter, but we just do that to connect up over here. And then with our second number here, we're going to make it be 0001. I believe that B0 is the least significant bit, which is what we're doing here. We're creating basically it's 1. We're just adding 1 to it, 1 in binary to it. And then we add those two together, and then that's going to trip us over into... Actually, I'm not sure it's going to work. I'm not sure it's going to work. If you add 0 and 1, isn't it just going to be 1? I don't know. The only way to know is to try it. So let's try it. Okay, well that worked. We got a 0 from 0. Step 1. Step 2. No. The input was 1 0 0 0, and we got 0 on the outputs. Why did we get... What should we have gotten on the outputs? I thought we were supposed to get 0 on the outputs. What am I missing here? Isn't that what we're supposed to be getting? Are we supposed to be knotting it later? Original, one's complement. See, we can't add all 3 of these things simultaneously, right? We can only do, stripping off the leading 1, we get 0 0 0 0. Which is, I thought, the answer. Followed by adding 1, any number obtained in this fashion yields us. Okay. Well, I'll tell you what, I'm gonna have to take a look at this again. So give me just a sec to think about it. Well, okay, actually maybe graphically we can understand this better. Just looking here, green is high, red is low, right? 1 0. So if we look at what's happening here, we've got 1 0 0 0, right? And then we're flipping that here to be 0 1 1 1 1 0 0 0 0. We're adding those together, and that's giving us 1 1 1 1 1. But what we really need to do, don't we need to now flip this would that give us the output we wanted? I don't think it would, because on this first one here, we get it right. And if we were flipping it here, then we would be flipping it here, it would be 1, 1, 1, 1, 1 plus 1. Well, you know, all we can do is try it. Let's try it and see if maybe that's it. Surely we don't need 2 NOT gates, but I don't know. Let me see. Okay, so maybe this is the answer. What if we just put a full adder instead and have a high on the carry in and dispose of the carry out like this? Will this work? I don't know. I didn't think it would. Okay, well, it worked for the first problem. This carry in should be bringing in just a 1, I believe. And no, that doesn't work either. That gives us exactly the same solution. So what is the solution? I don't know. It would be nice if it let us go past this problem here, right? This step of the simulation, so that we could see what else we're getting wrong, because I'm not knowing what it is. Or if we had a truth table or something. I'm finding it hard to troubleshoot this because I don't know what it's expecting. I don't know what we're supposed to be getting here. It would be my understanding that our output should be 0, 0, 0, 0. Maybe I've got either I'm not understanding it, or maybe there's a problem here. It doesn't seem likely that there's an error, because somebody would have pointed it out by now. But I'm going to go check on the forums, and we're going to see. And I guess I'll be back much, much later after exploring this some more. So I will see you guys later.